And welcome. Thank you very much for coming and visit with us today on our presentation on achieving net zero carbon emissions in U.S. agriculture through soil health. We're really happy you're able to join us. My name is Wayne Honeycutt, and I have the pleasure of serving as the president and CEO of the Soil Health Institute. We are a 501c3 nonprofit established by the Samuel Roberts Noble Foundation and the Farm Foundation back in 2015 to safeguard and enhance the vitality and productivity of soils. Before we get going, I thought it might be nice if we just take a quick look, so to speak, to see who is in the room. Thank you, Warren, for showing our polls. It looked like that about 35% of the attendees are scientists. A very close second, I guess, is consultants, advisors, educators. You all can see the distribution. So I think you can go ahead and close that. Thank you very much. I wanted to kind of fill you in a little bit on the format for today. We're going to really kind of consider it a panel format. I think it'd be easiest this way to kind of get through all the presentations, and then we'll have some good Q&A at the end. So we'll have 5 presenters, each of us given about 10 minutes to give our presentation, and then we'll have a Q&A at the end. So I'll be the first one to kick it off. I've already introduced myself, but then secondly will be Dr. Christine Morgan. Christine is the Chief Scientific Officer for the Soil Health Institute, and she's responsible for developing and establishing the scientific direction, the strategy, implementation plan, all those aspects for the Soil Health Institute. And then secondly, then we'll have Mr. Ryan Ciroli. Ryan is the Global Row Crop Sustainability Director for Cargill. In that role, he's responsible for leading the strategy development and implementation of their whole sustainability programs and initiatives for row crops across Cargill's enterprises. And then next, we will have Dr. Diana Bagnall. Diana is a research soil scientist for the Soil Health Institute. She does many, many different things, as you quite imagine. We're very happy to have her. She kind of keeps us straight on a number of different aspects and projects, and she will be sharing some of those with you today on her presentation, looking at calculating improvements in water holding capacity through soil health and things like that. And it's all through carbon that we can get there, mostly through carbon anyway. And then we're happy to round it out with Mr. Leo Pradella. Leo is a senior manager at the Walmart.org team, where he leads the implementation of their philanthropic portfolios for the Walmart Foundation in areas of regenerative ag and deforestation. So I think we just go ahead and I'll kick it off with the first presentation here, and then we'll kind of get rolling. So I think it's quite clear that the science, at least, is quite sure and very clear that we can significantly reduce greenhouse gas emissions and increase carbon sequestration, have many other environmental benefits and production benefits like yield stability by improving soil health. But we really wanted to kind of put the numbers to it and really kind of investigate just how effective we could be at achieving net zero greenhouse gas emissions in U.S. agriculture by adopting soil health practices. So in the next slide, you'll see that although agriculture only contributes approximately 10% of the U.S. greenhouse gas emissions, it's still a formidable amount. And of course, we all need to do our part. And so in the next slide, you'll see that there are a number of conservation practices that have been identified for reducing greenhouse gas emissions. In fact, USDA's Natural Resources Conservation Service has recognized some 29 practices for reducing greenhouse gas emissions. And when I say recognized, I mean that they provide financial and technical assistance for farmers and ranchers to adopt those practices because of those positive environmental benefits and other benefits that they can have. So what we've done is to start to ask that question, is it achievable? to get to net zero greenhouse gas emissions through soil health practices across the entire U.S. agricultural sector. We started looking at some of those practices for which we could find data. One of them, prescribed grazing on the far left on the table. The other one, cover crops, no-till, nitrogen management. And then we started looking at the total capacities for each of those practices. There's about 655 million acres of rangeland in the U.S. And there's about 396 million acres of cropland in the U.S. But going back up to prescribed grazing, you can see that according to ERS reports, only about 7 million acres, or only 1% of U.S. rangelands, are using prescribed grazing. So we have a huge way to go, but also a huge opportunity there for sequestering more carbon, reducing greenhouse gas emissions through further adoption of prescribed grazing. With cover crops, only about 4% of our cropland is currently using cover crops, and that's from pretty recent data from the Ag Census. With no-till, doing a bit better, but still only about 26% of our cropland is using no-till, and about 35% is using nitrogen management. And of course, when we're talking about greenhouse gas emissions, where that really comes into play is the reductions of nitrous oxide emissions, which is about approximately 298 times more powerful than CO2 on a kind of a molecule to molecule comparison. So this is kind of our first estimate of really looking at, okay, what additional adoption potentials are there? And so then if we could show the next slide, what we then did was start to look at what the U.S. EPA, Environmental Protection Agency, estimated to be the current greenhouse gas emissions every year across the entire agricultural sector in the U.S. So that's that red line that goes across the top. So they tell us that the U.S. agriculture sector emits about 582 million metric tons of CO2 equivalent per year. And so we just started there on our graph in 2020 and said, let's just assume that's constant. Let's assume it's not going to go up or go down, because that's basically our target that we want to use. And then we went to the literature and saw what people had been measuring and reporting in terms of reductions in CO2 emissions, increases in carbon sequestration that they were finding when people used prescribed grazing, adopted that practice. So that's the orange line there. And that's a reduction through that prescribed grazing adoption. But then we also wanted to add what some of these additional benefits are from the other practices. And so the yellow line right below it there, that's when we take the prescribed grazing benefits and we add nitrogen management applied on more cropland as we go. And then the blue line was when we add cover crops to that. And then the green line is when we add no tillage to that. Now, we realize that this is just a real big picture approach here. This is applying all of the same, carbon sequestration amounts and the reductions in greenhouse gas emissions all across the U.S. And we know that it's not like that. We know that different soils have different capacities to sequester carbon, for example. But this was just really kind of our first attempt at, just taking that big picture and answering that big picture question is this possible? We also know that many of these practices are likely not additive in their effects. And that is, in fact, what we've done here is we've just added the benefits from one on top of another. But, there's plenty of research done and others that can be done that can really tease some of those things out. And when we're on a given soil, on a given farm, we can really closely estimate that carbon sequestration capacity of that particular soil. So again, this is not for getting at the most definitive answer. This is to tell us directionally, is this possible? And we feel like that these results tell us that the answer is a definitive yes, that it is very possible. But it's also very clear that what this depends on, our success, really depends on adoption. So I would like to share with you our next slide on that strategy for achieving those levels of adoption. Now, so adoption here is shown in the green box, and this is the Institute's comprehensive strategy to increase adoption of soil health management systems. But since carbon is just so central to soil health, and when we're influencing soil health, we are influencing carbon in almost almost all of our practices and systems. That's why I'm sharing this same strategy with you here. And so again, adoption is our goal, but then it depends on what a producer needs to know when he or she is deciding whether or not to adopt those practices. And what they tell us is that they need information on the business case, that box labeled number 1 up there. Information like, is it going to be profitable? Is it going to increase or reduce their economic risk? But then they also tell us that they need to know the best way to measure soil health. And of course, we need refinements in more efficient, economical ways of measuring carbon too, as part of that. It's really kind of unfair of us to ask farmers to monitor and to manage something if we can't really tell them how it should be measured. And so providing effective measures so they can know their current status and monitor their progress at achieving soil health and improving their carbon storage in their soils, that's very, very key. Education and training is another very important aspect influencing that producer decision for adoption. And we feel like it's really important that education and training be very local, very locally tailored. Not only for given soils and climates and production system, but also even for a given farm, really quite personalized for a farm and their farmers and ranchers' individual goals. So those are 3 really kind of important aspects influencing adoption. Of course, all that is backstopped by a firm research and development program. And that's in box number 4 over there. But we feel like that even when we get those levels of adoption, it's really important that we do not stop there, that we then follow up and quantify the impacts of that adoption. Down at the bottom of this chart, box number 5, because when we look at the impacts of adoption on things like productivity, then that feeds right back into supporting the business case, but also quantifying impacts on adoption on things like carbon sequestration and water quality. Then that really helps us inform our policies. And it also really helps us kind of essentially have the ammunition that we need for educating consumers of the environmental benefits, because we feel like that once those consumers are educated and on those environmental benefits of the food and the fiber and the fuel that's grown using these soil health systems, then what essentially it can do is it create more market demand for those systems and for that food and that fiber and that fuel that's grown using those soil health systems that have these climate benefits, that have the water quality benefits and the pollinator benefits. And so all these things are obviously all linked together. But my point is that at that point, it can become more of a self-sustaining system. So it's less dependent upon the scarce federal and other resources for helping people adopt these practices, but the market can really kind of help drive that demand and drive that adoption. And so the next 4 speakers that you're going to hear in our program today are going to address these top 4 boxes here. Dr. Morgan's going to look at filling these the adoption gap for the most effective measurements. Ryan Ciroli is going to talk about filling the adoption gap with the business case for soil health. And Diana Bagnall is going to be talking about some of the technology aspects. And Leo Perdella is going to be talking about some of the education and training programs, again, for filling those adoption gaps. So I will quit there and turn it over to you, Christine.
Hey, thank you, Wayne. Well, as Wayne said, today I'm here to talk about how we can fill that adoption gap with knowing more about how we can effectively measure and monitor soil health in our farms and ranches. So, the first thing I want to show you, because I'm a soil scientist and I'm always ready to engage people and show them how interesting and amazing soil can look, is these are two pictures of the same soil. They're essentially just across the fence line from each other, and they've been managed in very different ways. This is actually a soil from my home state, Texas. It's the Houston black clay. So it is the high clay, very productive agricultural soil in Texas. And on the left-hand side, this soil has high carbon and good soil structure. And this is one of the things when we're talking about soil health and we're trying to quantify, not all soils look like this soil, but this is an ideal photograph of a soil to show you how the roots are integrated into the soil. We have really small PED units that allow the water to infiltrate into soil and redistribute and be available for the plants to grow. And on the right-hand side, it's the same soil, and all we've changed is management. And this side, it's been plowed a lot, compacted a little bit. This is about as bad as the soil can look. It was captured in a time when the ground was dry. There had been a plowing, and then the soil just kind of got mushed a little bit due to the management that was going on. And you can imagine if you were an inch of water and you fell on the soil to the right versus the soil to the left, you can imagine that you had a lot more places to go on the soil to the left because of all the different crevices between the little PEDs. Whereas on the right, there's just fewer places to go because you essentially are not just going to infiltrate into the total soil matrix, but also infiltrate rather quickly around those PEDs. And those PEDs are quite larger. You can tell the scale on the right-hand side because of that shovel. And this is what we're talking about, soil health and improvement in soil condition by increasing the carbon in it. And we know that beyond carbon sequestration, there's a lot of other benefits to improving our soil health. And so the question is, if we treasure this transformation of improving our soil with management, how do we measure and monitor it? Because ultimately, if we can't quantify those changes, then it's very hard to document, record, and talk about it. And it's very easy to see in this picture because I chose some extremes, but of course there's all the integrades in between. And so that's what I want to talk about today, is this need to get standard measurement of soil health. And scientists, soil scientists, agronomists, others that work in managing soil, rangeland ecologists, we all have different ways that we want to measure our soil. It depends on the hypotheses, our specialty, what we're really interested in. But what we're trying to do at the Soil Health Institute is come up with a few basic standard measures that we can all take, and also to help our farmers, our crop advisors, our ag retailers, our policymakers, anyone that's engaged in the improvement of soil, monitor these changes and monitor it in meaningful ways. So the way we got to this is we started this project. Next slide. And the project is called the North American Project to Evaluate Soil Health Measurements. The goal is simply, and I say this tongue-in-cheek, simply, identify the most effective indicators of soil health. And our approach is to look at long-term agricultural research sites across the continental North America. And these sites, we wanted them to have treatments of where business as usual, or some treatment that is local and reflects the cropping systems of the area, and then also have improvements in these management that we know do affect and improve our soil health. So for each of these sites across North America, we have this paired experiment of business as usual, for lack of a more general term, versus improvements in soil health. And before I go to the next slide, I just want to acknowledge our funders, General Mills and Foundation for Food and Ag Research, as well as our partners in the project, which is the Soil Health Partnership and the Nature Conservancy. And all of the scientists, you're about to see the map, that have contributed their long-term sites to this project. Next slide, please. So first thing that we had to do is get a community of experts, these people that are measuring soil, that are testing effects of agronomic management on soil health and how that soil changes. And so we had multiple panels of experts come in. This one photograph of the faces you're seeing are experts across North America that do a lot of soil health measurement, chemists, physicists, biologists. And what we do is we engage them and ask them, what should we be measuring? And more importantly, how should we be measuring it? Because there's multiple different techniques for these different measurements. And we also engaged another group of scientists and we looked at 154 sites that were volunteered for us to come measure. And we just looked at their experimental design and thought through the statistics and chose the sites that we thought would be most contribute to the question at hand. Next slide, please. And so then we also have these indicators, and I don't want to go into them today. We don't have time, but essentially we had over 30 different indicators of how soil can change with management. So these are measurements. And if you're really interested in them, you can go to the Soil Health Institute website. If you don't like to navigate, if you're impatient like me and don't like to navigate websites, you can just Google Soil Health Institute measurements and it'll be the third hit, or actually the top 3 hits that you will get in your search engine. But essentially, we looked at chemical measurements, physical measurements, lab and field physical measurements, biological measurements. We looked at the soil health indices that are out there, such as the Cornell Soil Health Assessment. And also new measurements that just kind of popped around that we thought, oh, maybe scientists or farmers and CCAs could use this measurement. Let's see how good it is, how robust it is. Next slide, please. And so here is the beautiful color picture of North America, and it shows the geographical distribution of our sites. So all the black dots on this map show where we had long-term experimental sites that had controls and treatments of soil health management practices. And these sampling locations, you can tell they're in Mexico, the contiguous United States and Canada. And our partners in Canada were Agriculture and Agri-Food Canada. And our partners in Mexico was CIMMYT, or the International Maize and Wheat Improvement Center. And then our partners across North America, it just included a lot of groups, including USDA, ARS, local universities, land grant institutions, and LTAR sites, just a lot of long-term sites. What we were looking for were soil health management practices at these sites, such as reduced tillage, various cover cropping strategies, crop rotations, organic amendments. There were a few others, but that captures the broad base of them. And, and the interesting thing about soil is always depends and it's always local. And we really wanted to capture, this concept that every area has its local cropping systems. And then in that cropping system, we can add soil health management practices. Also just wanted to note that the color that you see on that plot indicate a climate moisture deficit. So obviously the redder are hotter, drier locations, and blue is wetter locations. Next slide, please. Some examples of some of the measurements that we took. I just bring up this example because this is like a non-traditional soil science measurement, but it was one that I was alerted to that existed. And I thought, if we can measure soil health indicator with a phone app, that would be really applicable to those that are working in the field. And so this is just one example of some of the measurements we pulled. This is kind of the more fun example because the idea of quantitative measuring soil health changes with an app is really exciting. Next slide, please. And so lastly, I'm not showing any data today because I only have 10 minutes, and if I pulled up the data slide, we would be locked into a 3-hour seminar, and we won't want to do that. But what I want to leave you with is this is the idea that we are going to have a soil health measurement framework this fall. And we're really thinking about our stakeholders who need this measurement. And then lastly, we are communicating this information through a series of webinars for certified crop advisors. And you could just see the list of kind of webinars, and our partners with that are the Soil Science Society of America and funded by the Walton Family Foundation. And these seminars are free and available to anybody who is interested in watching them. And you can see there's 3 more. And the last one is about soil health economics. And with that, I'm going to hand it over to our next panelist who is speaking on that component of our work. Ryan, please go ahead.
Thanks, Christine. So I'm excited to be able to talk about filling the adoption gap of the business case for farmers, and the importance of, as we think about driving soil health adoption. And where a lot of discussion and opportunity when we think about the science behind soil health, obviously the potential impact of soil health, but it's up to farmers who are ultimately going to be the ones that make the choice to make the investment and to adopt these practices. And so we need to help better understand the economics, right? Better understand what does this mean for farmers as they look at different soil health best management practices. Next slide, please. We're investing in soil health as Cargill because it very much closely aligns with our purpose. And our purpose is to nourish the world in a safe, responsible, and sustainable way. It's ultimately who we are, and it's why we exist. And as the world faces some of these really extraordinary challenges, from climate change to food insecurity, delivering on this purpose is more critical than ever. And we believe that many of the solutions, can be found in the very place that our food system begins, which is agriculture. And at the foundation of agriculture is soil health. Next slide, please. And soil health informs a lot of, or touches a lot of our own sustainability commitments and how we're looking at achieving a lot of our goals. And so whether that's looking at climate change and obviously addressing our science-based targets to reduce emissions in our supply chain, or as we look at our science-based targets for water resources and think about how we either restore water in stress areas or reduce pollutants. But also as we think about farmer livelihoods and how do we advance that education and training around sustainable agriculture, or providing market access that really helps support farmers and, again, that economic or business decision to be able to bring these things to life. Next slide, please. Soil health is really, again, is kind of the umbrella over a lot of our efforts. And we felt that there was a need to support maybe a bigger commitment, right, to support farmer-led efforts to really adopt these soil health systems, these soil health practices that are foundational to regenerative agriculture, and to look at that across 10 million acres of cropland in North America over the next 10 years. Next slide, please. We do this because we know that healthy soils, obviously, the topic of our conversation, can sequester carbon. But we also know that by adopting principles such as, or practices such as utilizing cover crops and no-till or reduced till, we can improve water quality. We can improve water holding capacity, drought resilience, a lot of those benefits for water. But we also believe that when we embrace soil health, that we can reduce our inputs, we can improve productivity, and thereby improving margins or long-term profitability for farmers. And it's about putting all of these things together in a way that makes sense both from the environmental standpoint as well as for the farmer standpoint. And to get there, next slide, please. We really need to focus in on that business case. And so we see soil health as an investment, and it's a long-term investment. And we have to understand that in those early years, right, and when we begin, a lot of times there are some risks. There are some real risks that farmers have to think about in terms of how they implement the system and what does it mean for them. And we could spend all day talking about ways to mitigate those risks and how we manage around that. But longer term, we believe very strongly that the system in of itself, there's a strong business case to be had to support adopting soil health management, because the system should be more profitable for farmers, while also bringing the value of all of those environmental benefits, those ecosystem service outcomes that we're looking for. Next slide, please. So this has led us to really, I'm very excited to be able to have supported some great work that was already initiated through the Soil Health Institute in partnership with the USDA's NRCS, also in partnership with the National Association of Conservation Districts. And they had started with the goal of how do we assess the profitability of soil health systems, and do that through calculating and integrating enterprise budgets, and doing that through the combination of on-farm data or on-farm actual management practices and costs, and tying that back to the long-term experimental settings that Dr. Morgan had referenced. And so we were excited to be able to just build on that, right, and expand the scope of that. And so we, over the course of the last year, the Soil Health Institute has worked with and done surveys with 100 farmers across the Corn Belt and across a broader region than what we had started with, to be able to better inform what's happening locally. So often we hear from farmers, well, that case study is interesting, but it's not my state, or that's not my county. And so we wanted a broader array of input from farmers in a broader geography to help better inform this. Next slide, please. And it started with those long-term research sites. So where we have the science that we're, for 10 plus years of soil health research. So we can understand in different latitudes, understand in different soil types, understanding in different growing conditions, the effects that has on soil health and soil health management. And when you pair that science and that long-term research with actual on-farm practice, we should be able to create a much more robust understanding and pretty informed understanding of that combination between science and economics to help farmers make better decisions. Next slide, please. We focused in on these key states to start with, and identified, again, 100 farmers who are already adopted soil health management to some degree or another, and surveyed them, right, and got some understanding of their current practices, their perceptions, and their cost of production, to be able to build out. Next slide, please. What we hope to be able to share by this time next year, really more localized partial budgets, right? So being able to understand what were the costs, what were the benefits, and how do farmers have a more informed understanding of when you adopt these different practices, what does this really mean for your overall farm income and profitability? Next slide, please. So while we don't have those results yet, right, we're 1 year into our 2-year research, we did have some early results that we thought would be useful to share, right, or at least understand kind of what we looked at. And so as we looked at those different practices, a lot of focus on things like no-till, strip-till, reduced-till, as well as cover crops. And for the farmers that participated, you see we have a very high adoption rate of no-till. And what's interesting is in places like in Minnesota, where I live, we're in the single digits with adoption of no-till. And here, greater than half the farmer participants had provided input. And so it should be very informative to help us understand, in even some of these areas where we perceive a very big barrier to adopting practices like no-till, to better understand the implications, or strip-till for that matter. Same thing with cover crops, right? High adoption rate of cover crops with our farmer participants. Whereas nationally, I think, as Dr. Honeycutt shared, we're in the single digits with cover crop adoption, and here we're much greater percentage. And so it should again help to inform when you paired with the economics, helping farmers make better decisions. Additionally, when we look at things like for our fertilizer management, we had high adoption rates of that as well. And again, I think it just another thing to look at and understand the economic implication. The other thing that I think is very important is we looked at farmer perceptions, right, and the social aspect of this. So not only just the economics, but understanding how do farmers perceive the benefits of adopting soil health management. And what's really interesting is we see this, perception of increasing yields across, the vast majority of these farmers, while at the same time being able to reduce inputs. And so to me, that's where the magic happens. So if we can improve productivity and we can decrease inputs, that should lead to greater margin, greater profitability, and that's what we hope to back up. But there's all the other ancillary benefits with things like, increased crop resiliency and the ability to get into the field, improvements in water quality. And so we're capturing all of that information that should lead for some pretty exciting findings and that we'll be able to distribute broadly next year. And the last slide, please. So in summary, I'd just say that we really view agriculture as a solution, and as this giant opportunity, and how we can solve some of the world's most pressing challenges, from climate change to water resources, while building an environment that really should lead to a healthier, more resilient agriculture system that leads to greater farmer profitability. So thanks for the opportunity to talk about the business case.
Thank you, Ryan. The next speaker up is Dr. Diana Bagnall.
All right. Well, I have the pleasure of getting to visit with you today about filling the adoption gap with new technology. And there are two technologies that I'm going to talk with you about that the Soil Health Institute is involved in. The first technology has to do with plant available water. And so in this first slide, I'm going to kind of set the stage to get us all on the same page about this very important co-benefit of increasing the carbon in our soils. So in this little cartoon, I've shown a volume of soil, and there's water held throughout these pores that it can supply to plants. But so that we can see it very well, I've designated this blue rectangle to be the plant available water. And this is a capacity of water, so it can be refilled throughout the season by irrigation or by rainfall. But what's important for us to focus on today, and I'll show you in my next slide, is that when we adopt soil health management systems, what we can do is actually increase the volume of plant available water as we increase our soil organic carbon. That concept is not new, but what we've done here at the Soil Health Institute is provide a way to predict, when we change our soil health management systems and we increase our organic carbon, how much plant available water we can expect. So in the next slide, I'm going to show you a little bit about a new predictive model that has been developed from the NAPSHM data, the North American project to evaluate soil health that Dr. Morgan introduced. So this graphic on the left-hand side, the y-axis, shows available water holding capacity in percent. You can think of that as the size of that blue rectangle that we saw a moment ago. And we have different clay contents on the x-axis because the percentage of sand, silt, and clay in our soils does tell us something important about how much water our soil can hold. Where the predictive nature of our equation comes in is that now we can estimate when we have 1% organic carbon, for example, at that first blue line, what then would happen? How would we increase our soil organic carbon to 2, 3, or 4%? And then what would the associated change in available water holding capacity be? So for example, maybe my soil is a 20% clay soil. Initially at 1% soil organic carbon, I might start out with 17% available water holding capacity. And I can see I could increase that to 25% if I could raise my soil organic carbon to 4%. Now, it may be a little confusing or not super meaningful talking about this in available water holding capacity and percents, but the important part is that this is going to enable decision support tools that can then calculate the gallons of water or the inches of water that we can provide to a crop, which of course is very important for farmers as they consider these practices and the impact that, or the co-benefit of providing water to their crops, of increasing their soil organic carbon. On the next slide, I want to show you a particular decision support tool that we're already working with. So on the left-hand side, I'm just showing the exact same equation to symbolize the work that we've done in this decision support tool, and then how we're going to plug it in to Comet Farm. If you're not familiar with Comet Farm, it is the carbon management and emissions tool developed at Colorado State University and supported by USDA. And the purpose of this is that an ag manager can go online, can look up their particular field, and then play through a scenario where they could say, maybe I want to convert from a conventional tillage system over to no-till and cover crops. Existing algorithms in Comet Farm will already tell that individual how they would reduce their emissions and how they would increase their soil organic carbon. And now, with this work, they can pair that with an estimate of additional inches of water, additional gallons of water that rainfall or irrigation can provide to their crops and that their soil can hold. So we're excited about this. I'm from a dryland agricultural region, and I know that this is a very important co-benefit of increasing our soil organic carbon. So that is the first technology. The second technology I want to talk to you about is about sampling soil organic carbon. But before we get into that, in the next slide, I want to set up the motivation for why we want to change the way that we sample soil organic carbon. So on the left-hand panel here, we have a map, and it is mapping organic carbon across a 60-hectare field, or it's from Western Australia, so maybe I should say a paddock. And the organic carbon was sampled from 0 to 10 centimeters depth. What I want to take away from this is very simple, that the range in carbon goes from that white color at about 0.5% all the way up to over 4% in that dark color. So that's a pretty substantial change across this one field. So kind of put a bookmark in that thought, and let's move over to the right-hand panel now and look at organic carbon with depth. So in this graphic, from a different study, we're now looking at depth on the y-axis from 0 to 0.4 meters, and then on our x-axis from 0 to 0.8 meter, or 8%, we have our soil organic carbon measurement. Now there are two types of dots here. You see light or white dots, which represent a conventional tillage system. And then in a very similar soil, they're also looking at, in the black dots, a zero-till system. So there are several things that we could take away from this graphic. One is that there is a change with management. We also see standard error bars, seeing that there's variance even with depth. And then there's a pretty substantial change in depth there from the surface down to roughly 0.5 meter. But really the takeaway I want you to hear from or see from this graphic is if we look at the scale, 0 to 0.8% soil organic carbon, and we compare that to the change across the landscape, you can see that the changes with depth are dwarfed by this really huge change across a landscape. And the result of that is that we have to take a lot of soil samples in order to characterize soil organic carbon in a field that we may be interested in measuring. So these facts lead us to my next slide, in which I want to talk about measuring our soil carbon stock. So in order to convert from a percent of carbon, which is what we've been looking at so far, over to that stock, so maybe we would think of metric tons of CO2 equivalent per acre, we have to measure the soil's bulk density, and we have to do that with a known volume of soil. So this core that you see here is an example of a bulk density sample. That particular sample is to 15 centimeters depth. So we've hit the first bullet point. We have to have carbon concentration and we have to have a bulk density sample to get carbon stock. We saw from our last slide that we need to take a lot of samples across the landscape, and that means we have to take soil cores back to the lab to measure bulk density. We have to dry those and weigh them. And even though this little core is only 15 centimeters deep, we need to sample to at least 30 centimeters depth, and maybe in some cases as deep as a meter, depending upon our question. And this all adds up to a lot of time, a lot of transportation, and a lot of costs. So to avoid this and find a better way, on the next slide, I want to describe to you a new way to measure soil organic carbon. This is a project that is currently funded for the Soil Health Institute. We're receiving funding from the Department of Energy's ARPA-E program. And the heart of this is a penetrometer, which is a sensor that's mounted on a ATV, like you see here in this diagram. So we can drive across the field, we can scan down to a meter depth and get simultaneously bulk density and carbon concentration. We don't take any cores back to the laboratory. We digitally store that information, and then we use predictive modeling to get our carbon stock and enable our management decisions. So we're really excited about the opportunities that this will open up. And here on my last slide, I'm just going to briefly summarize the two technologies that we talked about. We talked about predicting changes in plant available water as a co-benefit of increasing soil organic carbon using our soil health management practices. And then we also touched on the developing rapid in-field carbon stock measurement technology that we're at work on today. So with that, I think I'm very close to out of time, so I will turn over the digital floor.
Good afternoon, everybody. So I'm Leonardo Pradello, just Leo. It's a pleasure to be here. Thanks to the Soil Health Institute for the invitation. On to the next slide, please. I wanted to just give a little bit of an overview. I work for the Walmart.org. I'm an employee of Walmart, but I have the pleasure of executing the philanthropic strategy for the Walmart Foundation on the subjects of regenerative agriculture in the US and deforestation. At Walmart.org, we believe that businesses, when they thrive, when they succeed, when they create value to society. And that requires a combination of elements. I have outlined some of the things that we explore, that we try to do through our team in Walmart.org. We complement some of the exercise that business can lead with philanthropy. By that, I mean enabling conditions, building characteristics that we can't see through, that we can't yet have a business case to go through our supply chains. On to the next slide, please. The Walmart.org team is divided in three main areas, three main portfolios. One that looks at creating opportunity for retail workers, another one on enhancing sustainability, which is the one that I have the pleasure of working in, and another one on strengthening community that also looks at disaster response and disaster relief. And all of these portfolios have a strong D&I lens to it. We invest in equitable outcomes. Something I want to stress, it's a journey that we're going through, not just the company, but also the philanthropic intervention from the foundation, something that permeates across all the philanthropic grants that we make and the corporate giving that we have. On to the next slide, please. I'll take a moment here just to reflect on what is our role, right? What is the role of each one of us? There was a poll right at the beginning of this discussion where we saw representation from all fields of work. And when Wayne approached me and asked if we wanted to speak about the adoption gap, what is the role that we play here, really? The Walmart.org team identify levers of impact that we can catalyze to philanthropy. Among those, of course, many of the subjects that were covered previously on innovation and technology, in some cases, remote sense monitoring, on-the-ground monitoring, field soil sampling collection, convening. How can we harmonize the discussion, right? I speak about regenerative agriculture. What does that mean, right? What we're talking about today about regen ag is very broad, very wide. In a similar vein is what 10 years ago we were talking about sustainability. Each person has their own definition. So how can we accelerate that? Can we all agree on core elements of it? And can we go after those elements in a concise way, one that acknowledges the role that each player has to play, the incentives that each one of them has access to, and what are the bottlenecks that we can drive interventions, either through business or either through philanthropy, that catalyzes action. And among those is the adoption of those regenerative agriculture practices. It's a challenge for sure, right? As it has been outlined by the previous speakers, there is a challenge that we need to come across in terms of is that viable? Can we, the other practices that we're talking about, can we approach a farmer? Can we request or can we ask a farmer to adopt them in a timely fashion? Does that make sense for him, her, or they that runs that farm? In the US, in many cases, it's not a matter of being more profitable. In many ways, a matter of staying in business or not. Right? We see a big consolidation of farmlands in the U.S. The number of properties is decreasing, but the area of land being produced is increasing. And so, how can we make sure that we can still see passage of lands through multi-generations in a way that is effective, in a way that is business conscious, but also acknowledges the planetary boundaries that we have? So, I'll give an example of this work that we have supported. On to the next slide, please. With the Soil Health Institute, a grant that Walmart Foundation approved for Soil Health Institute. Wrangler was also another one of the funders. And this one is a great exercise on reaching to cotton producers in 6 states across the US. I probably won't forget all the names, but it's Arkansas, North Carolina, Texas, California, Mississippi, and Georgia. So the leading producers of cotton in the US. And identifying what are the ways, what are the interventions, what is it that the farmer wants to hear, what can we display about the technologies, how can we simplify that language in a way that yes, okay, I see this is relevant. This is something that I can do. These practices are meaningful. They drive impact to my productivity. They drive positive impact to my livelihoods. And they, of course, they drive positive impacts to the environment. And so the Soil Health Institute has been leveraging quite a lot of the technologies that have been mentioned here before, and reaching out to farmers, building, as it's been described, as micro communities. What takes place in Georgia is probably not going to be the same way as it happens in California or Texas. The soil types are different. The types of farmer associations are different. The incentives that each farmer has access to may be different. And so it all needs to be tailored, even though we want to get the same outcomes everywhere. We know that there are local circumstances, regional circumstances that need to be accounted for. And that is what the program is designed to do. On to the next slide, please. And the approach for this program, it falls into the categories that you see here. It's developing tools that farmers can have access to. Not every farmer is going to be on the same place or going to see the incentives the same way. And so it needs to accommodate for farmers that are already leading, they already have implemented those practices, those that are curious but don't have the access to the information they need or to the financial resources, the financial incentives that they're procuring. And farmers that in many cases don't even own the land. That is something else that we have, the Walmart Foundation has supported through other grants of identifying how do you reach non-operating landowners, right? What are the incentives that the renters have to adopt practices, even though they don't own the land? They may have handshake agreements for a year or two. They don't have the necessarily incentive to go after this type of practice that sometimes can take years to materialize in profitability for their own farms. And so what Soil Health Institute has it implemented in such a good way is developing a plethora of tools. Essentially, there are training days, going to the field, workshops, a number of them across the different states, the 6 states that I mentioned, developing relationships across each one of them, with building and creating farmer mentors, those that have already implemented some of these practices that you saw listed in the previous slide in their farms, they have seen, they have tested, they've been through the journey and can attest to the success that they lead. How can that knowledge live within that community without a direct intervention? The Soil Health Institute, of course, and many of the other nonprofits can't be in every single farm at all times. So how can you simply share that knowledge in a way that is approachable, that people can easily access, and it makes sense to them? And so additionally, it requires technical specialists that can go into the field and explain why exactly it is that this practice is better than not doing this practice. Actually, I'm not the best person to speak to them, but the Soil Health Institute has a team that has been able to do that very effectively. And of course, the last one, advanced training, there's no definition there, but it speaks to longer term engagement with the farmers. One thing is to get in the first year and connect with an association of producers. Another thing is to come back next year, discuss with the ones that have gone through the practices and say, what changed, right? What are the interventions that you have applied? Has that improved? Can we modify the program, the management system that you're using? That evolution is what drives more, not just in terms of measurement, that we can get better information about what works and what doesn't work in each one of these different places, but also what is most relevant to the farmer. Right? We can spend all day talking about how companies can send signals. Walmart sends signals to our suppliers and upstream in the supply chain. But we also, of course, need to be conscious that ultimately these changes in agricultural practices are implemented by farmers. And so if it doesn't make sense for them, then it doesn't make sense for anybody. So with that, I'll just close the presentation. I'm looking forward to the discussion. And thanks again to the Soil Health Institute. I really appreciate the opportunity to speak and to learn more about the work of Walmart.org. By all means, please visit our website. Thank you.
Great. Thank you, Leo. At this time, we're going to transition to questions and having discussion. And so what I want to remind everybody that all participants can see the question and answer box, and you get to vote. And so it'd be really helpful if there are some questions that you're particularly interested in. and you vote on them, they'll get moved to the top of the box, which would be easier for me to see. I've read through all of them, and I want to try to get through as many as possible. And also just say that, we're really going to focus on those about soil health today, and carbon sequestration associated with soil health. So I'll start with that. And then regarding the panel, I can see all of your faces. So I will assign a question to somebody because we're virtual. But if you would also like to answer it, or a comment, because this is, we want this to be as much of a discussion as possible, you can just signal me with your hand and I will try to include you with it. Okay, so the first question with 15 votes, I think we better cover this one. It says, how is soil organic carbon sequestration capacity of a soil measured or determined? Okay, so I think if this question is stated as I read it, they're asking what is the capacity of a soil to sequester carbon and how is that determined? Well, based on the climate that the soil is in and the soil's inherent properties, such as the thickness of the soil, the amount of clay of the soil, the location the soil is on the topography, those all affect the potential or the capacity of the soil to sequester carbon. But if we are going to just measure the change in carbon, obviously, just like Diana said, we measure the concentration and the bulk density of the carbon at some time 0, or at the beginning of a change, or just any time. And then generally 5 years later, we would take that measurement again in the same location. That's a pretty general sense of how to do it. But I think that I don't want to get too bogged down in the weeds on that question. I hope, Ellen, and the 15 people that voted for that question, that's a satisfactory answer. If not, you can follow up with me later. Okay, the next question that has 17 votes is it's a question about food supply chain, and this is really important. I've had a lot of discussions with people on this. The question is, and I think I will start with Ryan, and then if anybody else would like to add to this, we'll do that. But the question is the market ready to process a more diverse type of crops? As I understand the concept of regenerative organic agriculture, so that's 2 different kinds, regenerative ag and organic ag, it may require different types of seeds, different crops altogether, crop rotations to accommodate local regional conditions, availability of water, labor, socioeconomics. Has there been a focus on the supply chain to discuss adaptations required, thinking about fast food chains, processed foods? I think one of the questions that I've commonly heard is that if a producer wants a different price because they're raising their products sustainably, how does the supply chain respond to that in storing and transporting separately? I think that might be one of the questions. And then as far as a more diverse type of agriculture products, how does the supply chain handle that?
Well, I'll tackle that. So I think you can look at it through 2 lenses, or we're looking at it through 2 ways, right? One is you can think about what's happening on the demand side and the consumer side, and where is the opportunity to do things like we mentioned, regenerative organic. And so where there's certifications or there's specialty supply chains, we can build those, right? Those can be created, but that's a very different, when you're creating full traceability and segregation, there's a lot of costs, there's a lot of extra effort to do that. But as you see increasing demand, there's an opportunity to create those kind of demand-driven markets. The other side is how do you make this work at scale in the commodity side, right, with existing infrastructure and things like that. And so I think there's opportunities with farmers to think about things like ecosystem service markets, and how do we pay for outcomes like carbon, water, or water quality, water use efficiency. And so supporting things like that, I think there's a lot of traction and interest. And then within your own system, right? So, obviously where we can extend rotations or look at more diverse crop rotations, we know there's benefits. But even within a corn and soybean rotation, if we can, look at tillage and we can look at getting, at least cover crops, other things involved, there's a benefit. So it's about where are we starting in the journey? How do you engage farmers to get started? And then how do you advance along that? And I would also say, I think there is a place for other crops like peas, or, a lot of great work coming out of the University of Minnesota's Forever Green Initiative, thinking about things like camelina, pennycress. And so I think we'll see the rise of some of these other specialty crops or different crops or third crops in a rotation that both serve the needs of, they could be a cover crop, they could be another crop, but it takes time. And I think we just have to look at how do you scale that up. And I think we need all options on the table to get it done.
I was on mute. I'm gonna mark that one as answered, and I didn't see any of the other panelists wanting to chime in. So, oh, this is a good one. I'm gonna let Wayne handle the beginning of this one at least. Use of herbicides, glyphosate, is often part of corn soy production, but affects the soil health biome, the soil microbiome, and carbon sequestration, despite no-till. Not sure what that is, but I think the big question is use of glyphosate in the soil microbiome. Does adoption address reducing herbicides and high level of nitrogen fertilizers?
Yeah, thanks for the question. Yeah, I would say yes and no. I would say that there are situations that we see where people are not necessarily kind of aware of some of these, but the reality is that a soil health management system is just that, it's a system. And that means nutrient management is a critical component of that system. And it means pest management is a critical component of the system. And so when we help change our management practices, we are often influencing things like pest dynamics and nutrient availability. Just kind of, for example, just a cover crop. Now your nitrate is not leaching down to the groundwater, but now there's a much greater chance for that cover crop and the cover crop roots to be taking that nitrate back up and recycling it essentially into the surface soil or to the very top of the soil. And so there's now that opportunity and need for adjusting your nitrogen management plan, because now you have lost less. Now you can reduce perhaps your inputs because now you've recycled some of those nutrients back to the surface. The same way as even particularly if those cover crops are things like legume, that can fix atmospheric nitrogen. The air we breathe is about 78% nitrogen. And so these legumes, they have that ability to fix that nitrogen, bring it into that soil plant system. So that's another real example of how the nutrient management is a critical component of that soil health management system. But it goes on and on with pest management. There are some of these, that same example with cover crops. We all heard about like a glyphosate resistant pigweed. Well, one of the best ways now to manage that is for a cover crop. And so you're essentially shading out that pigweed. And so what that can mean again is those cover crops can be used for reducing herbicide application too. And there's more research that needs to be conducted on this, but there's a real opportunity for really impacting the microbiome by growing particular cover crops that can build natural disease suppression in the soils too. So I've probably spoken too long answering your question, but the bottom line is it's all a system. And so when we look at soil health management systems, all these different aspects of nutrient management, pest management need to be accommodated and considered as part of that soil health management system.
All right, thank you, Wayne. The next question is technical as well, but then I'm going to make sure that we give Leo a chance to speak. And though most of you would think that I should ask Diana this question, I'm going to field it, Diana, because I'm the project lead on the deep sea penetrometer, so I'll take it. The question is, what is the quantitative sensitivity that is expected for the deep sea penetrometer? And when do you predict this technology will be readily available? Well, the whole point of this type of DOE funding is to get technology to market. And we're thinking with our tech to market plan that, 2.5 years, and that we would be commercially ready and scalable, and maybe sooner, but that's roughly the estimation on that. And what is the quantitative sensitivity that's expected for the deep sea penetrometer? I'm going to skirt that a little because I think to answer this question for the whole audience, it might be a little easier to say that when we're proximally sensing, no matter what technology we use, we expect less sensitivity. But the trick is that we can take more measurements. And so as long as we're not biased in our measurement, we can take more. And you think about that bell curve, the more samples you get, the more accurate you are about taking the mean. And so that's kind of the concept behind proximal sensing, is just to get more cheaper measurements so that you can estimate the mean and not be sending loads and loads of soils to the laboratory. And if you want more detail on that, I'm happy to provide it. But I think for the audience today, I'm gonna leave it there. There are a couple of questions in here. By the way, audience, please keep voting. I think that's awesome. It's really helping sort out some of these questions. So the next question I think is for Leo and Ryan. There's a couple of questions in here peppered about giving premium prices for commodities that are grown in more healthily managed systems. And I'm just wondering if either one of you would be willing to comment on that and give us a perspective of where your communities are thinking about pricing. And I saw that Ryan took off his mute, but I would think it'd be great if both of you wouldn't mind answering that. So Ryan, please go first.
Sure. I might sound a bit like a broken record. I'm going to answer it a lot the way I just did the last question. Is where there's demand, sure, right? And I think where there's specialty markets where there's a clear demand that it's integrated into that, I think there's an opportunity. I would say for the vast majority of producers, this is why we're so focused on things like ecosystem service markets, right? So we've supported the Soil and Water Outcomes Fund in Iowa and an ecosystem service market consortium as potential outlets where farmers can not only market their grain or the crops they produce, their livestock, their physical products, but then also create new market incentive opportunities for them to be able to sell their carbon benefits or their water quality improvements. I would love to stack up as many of those outcomes as we can produce, biodiversity or habitat, right? I mean, and so I think there's an opportunity there. So how do you market those environmental outcomes that you generate, and then how do you market your physical product as a means of being rewarded for that? And where there's markets, like demand-driven premium markets, for sure we can facilitate it. Those are just way harder to create and realize the value than maybe there could be as we start thinking about outcomes.
I'll echo that sentiment that it depends on what commodity we're speaking about, which supply chain we're speaking about. There are opportunities for different types of contracts that may exist. And Walmart suppliers have access to those that report through Project Gigaton, the company's commitment to reduce emissions reduce 1 gigaton of emissions from our supply chains, have facilitated access to credit through a partnering financial institution. So there are opportunities to access incentives in some ways. But the true goal, and I think hopefully that was clear, is not to create niche markets, is not to create specialty markets. Those, as Ray pointed out, those are difficult to create, and most of all, difficult to sustain. And so it's a matter of what are how can we stack the benefits, the structure and the information that is needed to have this transformation at a broader landscape instead of just pockets of sustainable practices on the ground. So that's why we have investments on monitoring technologies, on tools, soil sampling tools, for example, convenience, facilitating discussion, facilitating access to information, and proving that business case that a more productive soil, a healthier soil is more productive and leads to increasing revenue at the farm level at a broader landscape. And so those things hopefully go hand in hand, and they have proven so far that they are. And so that is how we are at Walmart and the Walmart.org is how we are addressing this.
Thank you, Leo and Ryan. For someone who's always caught up in the technical component of things, I think that's a really helpful perspective to think about, raising it all, right? Getting it. So I'm going to skip a little bit because I feel like Diana hasn't had a question. I think she needs a question. So Diana, we know that carbon sequestration potential is kind of local based on climate, but how quickly would you expect to be able to measure changes in soil carbon in response to changes in management practices such as no-till or cover crops?
Yeah, great question. So I think that 3 years would be pretty early for most areas that we're looking at. And so we may be going out to something like 5 years. But certainly, if we were thinking of taking carbon measurements within a year of implementing a practice, we'd probably be unlikely to be able to do that. And if you think back to the map that I showed, we have to take into consideration the variance in the field as well. So knowing that those changes are quite large, we need some time to build up those management changes. So a rough estimate, 3 to 5 years, I think would be pretty safe.
Okay, all right. And you know, also would just point out too, from our measurements, we're also a lot of the measurements that we're looking at have been spoken about that they're early indicators of change. And so, you know, one of the things we're doing with our project, even though the sites we measured are long-term, we are looking at the literature too, and trying to find, you know, what are some potential early indicators, right? Because you know, clearly you don't want to wait 5 years to find out if your management is changing things for the better. It'd be nice to have some other kinds of indicators, not direct carbon measurements. Thank you very much. Okay, here's a question. I haven't decided who to give it to. So one thing I'm wondering about is, do we know how much it costs a farmer to sequester a ton of carbon? What is the monetary gain produced by that ton to the consumer, supply chain company, or government organization? Same with other ecosystem services. I know this is a tough one, and I know that Diana has had some projects where she's worked with economists and sociologists, and I suspect, Diana, you don't have any hard, fast numbers, but you know, what do we know about these externalities that the farmer creates that are positive for society and through soil health? And you know, what do we know about the costs of changing practices, et cetera?
Yeah, so that's a really great question. And I think some of the economic work that Dr. Morgan talked about really is maybe shifting the focus and saying, what are the financial benefits of these practices to the producer? And then recognizing that there are also benefits of the carbon storage, and there are also benefits of the changes in the water cycling. And so I might kind of take that question and broaden it and say, we are so interested in soil health for sequestering soil carbon because it makes sense for the farmer, because it makes sense for these ecosystem service benefits. And we may come to a point where it's easy for farmers to access funds based on the ecosystem services they provide. That's not a reality in many cases. And yet still we see positive economic outcomes of adoption of soil health management practices and increasing our soil organic carbon. So I think that's what makes it, from my perspective, such an easy win, because we are getting the carbon and we're benefiting our profitability and we're benefiting our water and we're benefiting the stakeholders who are interested. So that's my kind of skirt around question.
Thank you, Diana. Wayne, globally, this one comment is, globally the contribution of agriculture to CO2 emissions is reported at 24% or higher. Can you explain in the estimate of 10%, what is included and excluded in the 10% contribution reported by the U.S.?
By the EPA? It's been a while since I read that EPA report that described it, but they had things broken down in the different sectors, as you saw on that one pie chart, the transportation sector and et cetera. But I felt like that they were pretty inclusive for everything and for agriculture in the U.S. I'm not aware, I did not, quite frankly, look at other estimates in other countries that you were referencing with that question. But, you know, I felt like that EPA was very transparent in looking at all the different aspects of the agriculture sector in that number.
Right.
I'm sorry, I can't answer why other countries found other things. Diana may have additional information on that. I think I saw her hand raised.
Yeah, I saw a few questions regarding this. So to clarify, we are accounting for enteric fermentation of livestock in that calculation and manure management. But what's not included in that particular greenhouse gas inventory that the EPA has put out is the electricity costs on farm. So those are counted as in electricity themselves. So if anyone's interested, that's a bit of the breakdown. But you can access the EPA greenhouse gas inventory online if you have further questions.
Great. Okay, here I was worried that Diana wasn't going to get any questions, and she's getting a lot now. All right, one more question. What is the role of regulatory agencies in the U.S. and elsewhere in facilitating the adoption of soil health practices? I think this one is really interesting because, different countries have their different policy approaches. We talk about the carrot, the stick, and and also just let it roll, and whatever's most profitable will work. Wayne, would you like to comment on this one?
Yeah, I guess I'll take a stab at it. So in general, the federal government is hands off in the US when it comes to these types of practices, and in a regulatory way. The exception to that is when it comes to regulating wetlands and a wetland conversion, and when it comes to highly erodible lands. And so to the extent there's that interface between improving soil health, reducing erosion on highly erodible lands, then there is that regulatory connection. This is something that's, I think, quite interesting, because I feel like it kind of also gets at the heart of why so many farmers and ranchers farm and ranch. I think it's because of a livelihood and that's based so much on independence and being their own boss. And I think that to the extent that we can continue to make these conservation practices voluntary, I personally feel like that we can be more and more effective and in getting that adoption that we need. And I fear that having a regulatory tooth in it could turn some people away from farming and ranching. And we need them. We need them taking care of this land. A well-managed landscape can provide so many more good ecosystem services than an unmanaged landscape. And so I feel like that it's really important that we continue to look at some of the things like, for example, the economic benefits, so that we can get more adoption that way without a regulatory bite to it, so that we can build water holding capacity, like for Diana's project, so that farmers and ranchers are selecting these management practices because it can build drought resilience and therefore reduce their economic risk of being a farmer or a rancher, so that it can help them mitigate and adapt to climate change, and so that they're losing less of their nutrients to water. So now they can cut back on their fertilizer bill and these things. And so I feel like that so much about soil health is providing not only these environmental benefits that all the public enjoys and benefits from, but it's really helping the farmers and ranchers tighten up their nutrient cycles, tighten up their water cycles. And so I really have a lot of faith and hope, not just hope, but a lot of faith and confidence that this voluntary approach, when handled the right way and providing our land managers with the right information they need to make good management decisions, is going to be very, very strong, and is actually the best way that we can get greater adoption of these practices in soil health systems.
All right, thank you. Thanks. We'll leave with some optimism, and I would like to thank the panel today for your time and sharing your information and your experiences. I really want to thank the audience. This was a lot of fun. It is definitely a test in mental acuity, trying to go through all those questions and sort them out and delegate them to panelists, but it was quite fun. I hope the audience that you all got some new understanding about filling this gap and getting adoption rolling in the United States and by our farmers and ranchers, adoption of soil health management practices. And if you have any questions, you can send an email. I think it's on our closing slide, but I think it's info@Soil Health Institute. I'll let the closing slide come up. Yes, for more information, go to info@soilhealthinstitute.org, and we'll try to get to your questions. And please please feel free to rummage around on the Soil Health Institute website and see what all kind of information is there. There's a lot going on. Again, thank you everybody for your time, and have a great afternoon.